Alrighty, thanks. We're back with the last video. We did 19 last time. So now we're going to finish off. Let's see here. So we're on 20 and 21. Given the polynomial and one of its factors, find the remaining two factors. So I'll show you the algebraic method that we wanted you to do when we designed this problem. And then I'll show you the graph and calculator way to solve it. So let's see here. So one of its factors. So if one of it is a factor, that means it should divide evenly to it. It won't find the other two factors. Because x cubed should have like x times something, x times something, x times something, right? So because x times x times x is x cubed. So cool. So let's first go ahead and use probably synthetic division. So set it equal to 0. So we get x, we're going to plus 3 equals 0, minus 3 to the other side. So we get x equals negative 3. So we're going to use the negative 3 for synthetic division. Then we're going to bring down the 2, bring down the 15, bring down the, don't need a placeholder, so that's good this time. Bring down the negative 15. So bring down the 2, negative 3 times 2 is negative 6. And a 15 with the negative 6 is a 9. And then let's see here, so then we have negative 3 times 9 is negative 27. Negative 27 and 22 is a negative 5. And then negative 3 times negative 5 is a positive 15. Nailed it. So there's no remainder. Yes, it's a factor. So now we're going to go and write that down. So starting with 1 power less. So our highest power is 3, so we're going to start with 2. So 2x squared plus 9x minus 5. Cool. So one of the factors we know is x plus 3, but they want you to find the remaining two factors. Where do you think those two factors are going to come from? You guessed it. From this, what is that called? The trinomial? Quadratic function? Yeah, so from this quad. So we're going to just use regular parentheses to help us out on this one. You could do the box method, or grouping. And so we're going to go ahead and take, what does 2x squared factor into, you guys? So 2x squared factors into x and x, right? And then 2 and 1. So we're going to put a 2x here and a 1x here. And now we don't even have to use box method because 5 can only be factored into 1 and 5. And so we need it to be a middle term of 9x, though. So if I put the 5 here, probably won't work. Because 5x plus 2x is 7x, or 3x if we minus some. Yeah, so I'm thinking we're going to have to put the 5 here and then put a 1 there. Now we want it to be a positive 9x, so we're going to make it a positive 5 times 2 is 10x, and then 10x minus 1x is 9x. So there's our answer, 2x minus 1 and x plus 5. Cool. So there's our other two factors. So that's really the easiest way to do this as far as algebraically. I'll show you on number 2 how you can do it graphically now. So get out your graphing calculator. You're going to type in that problem. So x cubed, there we go, plus 3x squared minus 4x. And then we're going to go ahead and do a minus 12. Nice. So then we're going to go ahead and graph it there like that. Ooh, so I think I'm a bit too far zoomed in there. So how do I fix that? Do you remember? So go to the zoom button. Go to zoom standard. So that's number 6, zoom standard. That's going to give us that 10 by 10 graph that we usually always need. There we go. And so look at that. So our graph goes up, down, up again. So there is 3 factors. The first one it tells us is an x plus 2 as a factor, right? And so if you set it equal to 0 and minus 2 to both sides, x plus 2, the 0 is actually x minus 2. And so if we look on our graphing calculator, okay, and then we push the trace button. Wow, 0, negative 12 is where the y-intercept is. So right about here is where it should be our no, it's supposed to be a negative 2, isn't it? So we'll go backwards to x equals negative 2. Yeah, so right there is a 0. Yeah, look how close that is. But it's not right on it, Mr. Newbold. Well, that's okay. Well, I'll show you. Second calc, and we'll use the 0 function. So there's 0. So left bound means to go to the left of the 0, up there. Push enter. Then go down to push to the right and go to the right bound. That's a good right bound down there. Push enter. And it's saying guess. Well, I'm going to guess right about, I don't know, there. Okay, so it's going to 0 in for us and get our 0 for us. There it is, -2, 0. But Mr. Newbold, we already knew that. We're looking for the other 2. Oh, okay, sorry, yeah. So now you're going to use your graphing calculator and go do the same thing. But you're going to go to over here. There we go. Ooh, I'm guessing it's probably -3. Could be wrong, but I'm guessing -3. So go to second calc. Go to the 0 function there. So that's number 2, 0. Do a left bound. So go to the left, push to the left, push to the left. That brings us down a little bit, doesn't it? Now push to the right, push to the right, push to the right. That brings us up a little bit. Push enter. Now guess right about there. Push enter. And -3, 0 is one of our factors. So x equals -3 is one of our factors. X equals -2 is one of our factors. And then let's go to the right. And so I'm guessing that's a +2, but we shall see. Oops, too fast. Okay, so here it is. Well, that's going to be kind of tough, but we'll get it. Second calc. Go to the zeros. There it is. So there's our left bound down there. And then our upper bound, our right bound, push to the right, push to the right. That's kind of high, but that's okay. Push enter. And then right around there, push enter. 2, 0, x equals 2. So x equals 2 is our other 0. So there's our zeros, -3 and 2. And then you know what? For number 20G, or whatever that is, I actually didn't finish. I didn't finish this one. What do you mean, Mr. Newell? Well, that's just the factors. We actually needed the zeros. So that's just factors, but it's not the zeros, Mr. Newbold. So what do you have to do to get the zeros? Set them equal to 0. So this is going to be x plus 5 equals 0. So we have -5 to both sides. And we get x equals -5 as one of our zeros, a -5. And over here, we're going to 2x minus 1 equals 0. You got to set that equals 0. That's going to be a weird fraction. Set it equal to 0. Add 1 to both sides. So then we get 2x is equal to 1. Then we're going to divide by 2, divide by 2. So then we get x equals 1/2 as our other 0. Okay? So watch this video again to really understand how to find the zeros there. All right, so using your graphing calculator and using synthetic division. All right, 22, use the graph below to answer the following questions. So we don't have the function this time, so we're just going to have to guesstimate the best we can. At what x value does the function have a relative maximum? Is this the maximum? No, that's the minimum. Oh, here's the maximum. Yeah. So at what x value? Well, that's x equals 1 right there. That's x equals 2 right there. So then, x equals 2 about, yeah. So at what x value does the function have a relative maximum? X equals 2. Could you do that on the test? Find where that maximum is, that x value? At what x value does the function have a relative minimum? Well, here's the minimum. A little bit bigger than -1. We're going to just go ahead and say -1. But, -1 or -1, 0.1 or 0.2 would be fine. So either of those answers I would accept on the test. Along what interval is the function decreasing? Ooh, tricky. Remember increasing, decreasing? So decreasing is going from left to right. So always remember that, going from left to right. So going from left to right, here we go. So decreasing. Remember our little person? Yeah, Connor and Connor. Remember? So we go, decreasing, And so that number right there, so we said -1 or -1.2 is where we're decreasing. So from -infinity, going from the left to the right, -infinity to -1. So from -infinity to -1, we're decreasing. Then we're going to be increasing after that, so maybe we should do the increasing interval. Oh, but we're not done decreasing, Mr. Yeah, okay, you're right, we're not done increasing. So also over here at 2, and then to the right, we're also decreasing. Ready? Climbing, increasing. Oh, decreasing. Woo, this is so fun. Woo! Oh, I froze. That was cool. Whoa, it's gone. Where'd you go? Bye, Seth. Bye. Bye, Connor. So decreasing. So from, let's see here. So that's x equals 2. So we're decreasing now, still, talking about decreasing, and union with, and you can use parentheses or brackets. So I remember, I guess in calculus, they don't mind either way on the test for that. So you could use parentheses or brackets. So from 2 to the right. So forever decreasing, positive infinity. Yeah, he's way down there. Where did he go? Where are you? Come back. I'm kind of sad now. It's okay. We'll find him somewhere. Okay, there we go. So along what intervals is the function increasing? So we'll go ahead and use red there. Notice use green. So from -1 or -1.1, we're increasing until we get to that 2. That's when we start decreasing. So we'll say from -1 to 2, we're increasing. Cool. I'm using parentheses just because I like those as well. All right, excellent. Is the degree of this function even or odd? How can you tell? Well, let's see. It's doing the John Travolta, decreasing and then decreasing. So I'm pretty sure, I could be wrong, but I'm guessing it's odd. So then we could go on our calculator and see if we do have an odd function similar to that. What if I take this function we last did and put an ouchie negative in there, and then we go ahead and graph that? Oh yeah, from positive going down, and then up, and then down again. Well, let's zoom out there. I can't even see that. So yeah, let's zoom fit. Which one is zoom fit? I think it's 0, is it? Let's see me here. So zoom, wait, oh, there it is, number 0. Let's zoom fit that graph in there. So when we make that graph negative now, we're going to zoom fit it. There she blows. Whoa, cool. Yeah, so do you see? So this is kind of like that graph up there because it goes down, then up, then down. And so that means that the end behavior starts at positive infinity and finishes at negative infinity, and they're different. So is the degree of odd or even? Well, we're going to say, yeah, it's odd. Well, how can you tell? Well, it's odd because the end, go and write this down if you haven't already done so. What reason did you put? Maybe you were right as well. So odd because the end behavior is positive to negative infinity, and so so that's just like let's see here. So just like negative x cubed, which is also an odd function. Nice, cool. Okay, so is the leading coefficient of this function positive or negative? Well, we just kind of proved there that it's negative. How can you tell? Again, because the end behavior. So how can you tell it's negative? Because the end behavior, as x goes to the left, is y is positive. And then as x goes to the right, y is negative infinity. And so that's clearly the end behavior of like a negative x to the third or a negative x to the fifth. So similar to those end behaviors, and that's how we know it's negative. Hey, there's Connor. What's up, Connor? Yeah, man, you found me. Cool. All right, so finish up there. Good. So there's that one. So then we're going to jump over here to number 23. So this one we kind of haven't really talked about, but the easiest way really to do this is just to use your graph. If you want to learn how to do it without the calculator, I'll show you right now. But mainly, just start plugging it into your calculator. So go to y equals, and push clear. You're going to type in lots of parentheses. For those of you who want to learn without the calculator, basically these are your x zeros in parentheses, already been factored for you. And so we know that the end behavior, so it has to do with the x squared times the x times the x. And so x squared times x is x to the fourth power. And so that means the end behavior, oh, and then we have a negative there. Don't forget your negative. So that means the end behavior is what? X goes to the left. We know that y goes to the negative infinity, because it's going to go downward, isn't it? Just like negative x squared, or just like negative x to the fourth power, it goes downward. So as x goes to the right, y goes also downward. Cool. So there's the end behavior. I can't see. Where are you guys? There we go. So going downward there, let's see here. So that's the end behavior. Sketch the graph by hand or calculator. Label the relative maximum and minimum coordinate points. So by hand, you could actually do this. And how would you graph this sucker by hand? Well, we know it has zeros at -1, at x equals a positive 2 squared, which means it's a multiplicity of 2, which means it bounces. No, I don't think it bounces, does it? Maybe. We'll see. And then x squared minus 9, that factors into x plus 3 and x minus 3. So we should have zeros at 3. So let's put it there. We should have zeros at 3, at a -3, and then -1, and then 3, -3, 1, oh, and 2. Cool. So since this is x to the 4th, let's see here, x to the 4th. Ooh, this is going to be a tricky one. So I don't think I'm going to get this right because I haven't done this for a while, but we're going to try it. So we know the end behavior is -infinity. So we know this is going to go downward. Okay, we know that for sure. Now, the in-between is where we're not kind of sure there. So we know that it probably goes through at 3 and -3. So this will, let's see here. So that's right here. So it does go through. And then this one also goes through. But at x equals 2, it looks like it bounces. So we go boing. Because it's a multiplicity of 2, it bounces. So then at x equals -1, I think it also goes through. And but I'm not quite sure. So probably best if we look at the graph and see for ourselves there. Let's see if that's what it does. Maybe, maybe not. Let's see. So use the graph to help you. So we're going to go negative. That's it. Parentheses. And then x squared. And then a minus. Use the correct big minus symbol. So -9. There it is. Then close parentheses. X plus 1. Close parentheses. Open, close parentheses. And then x minus 2 all squared. So parentheses. X minus 2 all squared. Okay, so we're going to go ahead and graph that. Graph that puppy. Ooh, so it does kind of a cool, weird thing. Yeah, let's see. So I was kind of wrong there with the bouncing, wasn't I? But what the devil? Oh, yeah, Mr. Newbold. Man, you really botched that up. Good job. So the reason why is, wow, calculator's frozen. But the reason why is because we messed up somewhere. Where do we mess up? So let's see here. So we did have those 5 points. So we'll go ahead and get rid of that. Oh, it's because the x squared. That's right. So it turns out here even our end behavior was wrong. So we'll erase that. We'll erase that. Turns out it's not like x to the 4th or x to the squared at all. Why not? Well, because this is x squared times x. Oh, you forgot that x squared. That's right. So that's also x squared right there. So that's x squared times x squared is what? X to the 5th. That's why. So then x to the 5th is kind of like x cubed similarly. And so the end behavior for that one, it is negative though. So negative, so that's going to be like, let's see here. So yeah, positive to negative. So positive. So x goes to the left, we have a positive. And then as x goes to the right, we do have a negative. So then we're going to go here to the same points. And so the end behavior is positive going that way. The end behavior down here, as x approaches infinity, y goes to -infinity down here. Cool. And then let's see here. So we had the x squared was right. X equals 3, -3. So we did set those equal to 0 and get those correct. So again, now it's going to pass through the -3. And then it's going to pass through the -1. And then, like I said, x minus 2 all squared means to bounce. So we're going to bounce at 2 and then continue on downwards. Crazy, right? That's crazy. Now, the bounce part, let me show that to you again. So we go through, then we go up. And kind of a bounce, but a smooth touch is better than a bounce. And then goes down. Cool. So there we go. We're spending way too long on this video too. Wow, I didn't think this one was to take so long. Sorry about that, you guys. But at least it's working. So then, let's see here. So our graphing calculator isn't working. That makes me sad. So let me pause it for a second to pull up the graph and to find that relative maximum and minimum. So give me 1 second there. All right, excellent. So let's see here. There we go. So there we go. It's working again now. There we go. All right, so there's our, that's not our graph, Mr. Newbold. I know, it erased it because it froze on me. Dang technology, right? So basically, your relative maximum and minimum, you would use the maximum minimum on the calculator to help you find those points right there. So I guess you're waiting to see if you got the answer correct, right? So here's the end behavior, first of all. There we go. Now, so we got to plug it back in. I'll try to hurry to catch up with you there. So negative, and then we have x squared minus 9. And then we have an x plus 1. Thanks for your patience. Go grab a drink. Oh, no. Hurry back. I'm almost ready. And then x minus 2 all squared there. All right, there we go. So we'll graph that guy again. There we go. Wow, that's an ugly, yeah. So now I'm going to have to zoom out. Man, who came up with this? Is a beautiful practice problem, practice test. So hard. Don't worry, the test, we'll make sure it's a bit easier there for you. So we're going to have to go to zoom fit now. Holy cow, this is crazy. Okay, so zoom fit is going to be 0. So there we go. And so we need to find that relative maximum and minimum.